Yeah, welcome everybody for our fourth annual Invicro software user meeting. Thanks for coming here, and also everybody that joined us online for today's session. We already had a great workshop around VivoQuant scripting yesterday, which many of you attended. That I heard was very successful and was well received. And today we wanted to present to you a little bit of our work that we have done over the last year, as well as give you an outlook on what we as the software group at Invicro are focusing on, and give a couple of our users also a chance to present on their work, which very likely have similar problems that you have and used Invicro solutions to solve them. And I also hope that we have a lively discussion about things. So please ask questions. This is also more like a workshop where we can also go into more details of things that are of interest to you. So please feel free to come up with questions. We are also, that's not working yet. Yeah, we are also celebrating actually today the 10-year anniversary of Invicro. To the day, 10 years ago was our incorporation of the Invicro LLC, and we are having some internal celebrations also. But we also wanted to share this with you, and we should have a drink on Invicro later at the bar downstairs. I hope you brought the champagne or something.
We'll be champagne if we want it.
So, and with this, I would like to pass on to Bill for the introductory talk. Thank you.
Thanks, Krishan. And thanks everyone for joining today, both in person and online. We are excited for a robust discussion around, as Krishan said, how users both internally at Invicro and externally at pharma and academic institutions are collaborating with each other to solve these challenging data informatics problems in an effort to answer these even more challenging biologic questions and advancement of their drug development programs. As a play on our 10-year anniversary, I thought it'd be interesting just to look at how we got here. Our marketing group did a nice job kind of recapturing a brief timeline history of Invicro, and we've gone through a lot of change, or especially over the last couple of years. From acquiring companies, merging with groups, specifically around the scientific and operational capabilities of all these teams. And, most recently with the acquisition by Invicro by KM, really wanted to just highlight on a couple comments on what that means moving forward for our users and all the scientists that we work with day to day. Konica, after acquiring both Ambry Genetics and Invicro, really set out to form a advanced precision medicine group that is combining world expertise across different bioinformatics, quantitative biomarker disciplines, from genomics, histopathology to radiology. And Invicro, as we look at how we support and fit into that platform, we really view ourselves as a key data analytics technology driver of how to best leverage the current practices in managing data, viewing and analyzing data, reporting on that data from a variety of different modality types, whether it be a variety of modalities within radiology. With Konica Minolta, we've been advancing into the histopathology space more, and how best we can collaborate with our Ambry colleagues, as well as, I think, the quantitative biomarkers at pharma that are producing other data sets that groups are wishing to merge and to analyze in a cross-modality setting to answer these complex questions. And so the tools and the people that we have organized across the enterprise will continue to form into a group that will be made available to you as customers from a deployed software standpoint, as well as the continued engagement we have with many of our customers in the pharma data analysis space for the contract research services we offer as well. So very exciting times here at Invicro, and we continue to make investments in our company to stay at the cutting edge of how we think about data handling, data processing, and general data analytics practices. A little more specifics on Invicro. We continue to stay as an organization laser focused on radiology and increasingly some histopathology-based assays and the data handling tasks, data processing tasks that come with that. What may have gotten hidden from the large acquisition from KM was us joining forces with the Imanova team and their scientific group and operational capabilities, their site capabilities, Core Clinical, who their team has a wide breadth of experience in late-stage imaging core lab services, particularly on oncology, but other therapeutic areas. And so the challenges that our software team and the image analysis group here at Invicro kind of jointly face to help support the wide array of different types of data, again, from a data handling, data processing, data analytics standpoint, are only getting more complex, and we're looking forward to exploring how best to provide solutions, not just internally, but working with you as well, as we certainly appreciate and enjoy all the scientific collaboration with you as customers as we try to jointly build out these solutions to meet each other's needs. And how we envision the future building and supporting the wide array of these types of data sets is really continuing focus on the core software platforms that we develop in-house. But I think you'll hear a great theme today of how our software technologies can be incorporated into a wider picture, a larger footprint or ecosystem of different software tools for handling these different types of data sets that may fall within the radiology, histopathology category or complement to such. So you may be familiar with this diagram of how, iPACS currently and VivoQuant as a platform handle a variety of different preclinical and clinical data workflows, whether it's from a data sharing standpoint, data transfer standpoint, or from the nuts and bolts of viewing and analyzing the data. We continue to see iPACS as a core platform to manage and be a content management system for all things data related in imaging trial. And how we see the roadmap building out is where we can make investments on improving integrations to not just our own software, but other tools that groups are using, so that iPACS continues to be a center hub of the wheel, so to speak, of how you think about managing your image data. With that being said, the current environment is very interesting in how the landscape is evolving of how groups are thinking about managing not just image data, but all types of data within pharma. And as you can maybe see from a few slides ago, even at Invicro and working with our Ambry colleagues and our KM colleagues of how can we best think of iPACS as a component of a larger data management strategy, so that groups, when you have this single question of, can I look at a correlation of data output from a variety of quantitative biomarkers, that the technology and the infrastructure is not limiting to how you're accessing that data, how you're interacting with that data, how you're analyzing that data. And so that is really a core focus, and I think will be a theme of the year in how we work with groups, our current customers, our hopeful new customers we don't know yet, but hope to meet soon, and even solve challenges internally. And I think what continues to be such an exciting time at Invicro is the symbiotic nature between the problems that are presented to us through our contract research business and the problems that we interact with our customers using our deployed versions of software. We really see that line getting more gray in how we think about supporting these data handling, data processing, data analytic challenges. And so with that, I think, it's a great way to set the tone for many of the themes you'll hear in these talks today. I'll try to shut up quickly because we have a great lineup of speakers that will be touching on a variety of these topics. But, I think it's important, especially at a day like today, to really make sure that from Invicro, you realize how much we thank our relationships and our collaborative time with you as our users, and also our own team. So there's a lot of people here today, hopefully, that users, customers get a chance to meet. You see myself, TJ, Rhonda, Melissa as really been the main interface to you in a lot of these projects, but there's a huge team behind us that helps support a lot of the product development, the features development, general application support, technical support. And so it really, I hope everyone gets an opportunity to interact with the entire team here. That's from our side. And then again, we really should be thanking our users. You help drive our success. So with that, a little play on one of the first marketing campaigns we ever had at the company. If anyone caught it, I think it was back in 2013, but it was highlighted by a phrase, "See more." So let's help each other see more today, one voxel at a time.
Great. So now we are, since these early beginnings where I was Invicro's software and IT team for the first 2 years, we have now actually grown to about 25 software developers in the two teams led by Eli White and Gabe Tumon that you have just seen. And they are taking care of everything. So for me, it's nice to see that it takes 25 people to replace me in this job. But we have come a long way with this. And I want to go in a little bit into the latest iPACS release that we have, 2.03, that has been fully validated for the use in our core lab. I do have some bad news for you, kind of right at the beginning, that this release was mainly focused on our own internal core lab needs. But there are a couple of items that are still of interest for you that I want to get into. And I also want to show you a little bit of how we use multiple iPACSs that are coming together as different data marts for their specific purposes. And we built a fully integrated core lab workflow on these collaborating iPACS systems. So for us, for our internal needs, we completely overhauled the submission module, which is the part that Jacob also mentioned, where we are receiving images from the over 900 clinical sites and imaging centers that we work with worldwide. That is actually a module that's also available in iPACS to our end customers and can be really useful if you have to receive data and QC it along the way. But then for our core lab, we also had to build two modules, the query and the workflow. Queries are requests back to the sites when we have questions about the data that came in, QC questions. Then we have to fully track of all the communication, and that's done in that query module. And the workflow tool really is a complete integration of the entire processing pipeline and tracking every step and having accountability for every step along the way. I will show you a few examples of that along the way later in the talk. Otherwise, we really focused on improving and further improving the security and deployment of our tool, and I will also give you examples on that front. As for the user-facing changes, we continuously improving our job queue, which is the background indexing engine that looks at all the files that are on the system and extracts the information and puts them into the object relational database so that all the information becomes available for reporting, queries, searches, and so on. And since we are dealing with larger and larger data sets, like in Boston, we have 60 terabyte preclinical iPACS. We are continuously trying to catch up with that and improving the scalability of the job queue. Also on the web disk side, we further improved the search performance to get it more Google-like when you're trying to find files or patient information. And not unrelated to our new Japanese partners at Konica Minolta, where we also dramatically expanded our Unicode support on the system as global, so yet more character sets are supported and you can receive data in all kinds of from all places in the world. Also around searching, the image browser has seen many improvements, around, in particular about searching by date and date ranges. And last but not least, on the DICOM side, we made further improvements on automatic de-identification and mapping rules that allow you to more easily receive data and process this. But first, I would like to look into what are we doing at Invicro on the security side, not only to keep your data safe, but also the documentation that we collect around this to make it easier for you to use Invicro solutions in audited environments by us providing complete packages about our information security system, as well as the software development lifecycle that have been audited by farmer sponsors ours, as well as we engaged an outside consulting firm that does this so-called SOC 2 Type 2 certification for us. In this case, it's Kirkpatrick Price. We are just starting the third audit of this type, and it contains a look at all our service controls that we have in place, but also looks at the suitability and the correctness of the implementation. And what's kind of unique to the SOC 2 Type 2 as opposed to an ISO certification is that they also look at the operating effectiveness. So they don't just look into, do we have SOPs in place to handle certain situations? They also want to review after a year, did we follow them? How did we deal with deviations? And so that's why we decided that the SOC 2 certification is actually the best approach for us. We also get twice a year, our entire public network infrastructure gets penetration tested. We do web vulnerability scans that will also go a little bit more into details, in particular of the iPACS as a critical component. And we have the on-site visit to review the facility, any artifacts that we have, and all the documentation. And yeah, as part of the SDLC, we also have training records for every single employee. We do code reviews. We have a vulnerability management system and configuration management in place, and also have the documentation for you to more easily prove this in your own audit. And I mentioned that we already passed 2 of these SOC 2 audits in previous years. And also our IT infrastructure undergoes about a dozen audits from farmer sponsors every year. So we have about 100 audits that we passed under our belt. Since the iPACS, very often, in particular if you think about an iPACS where you share data or where you're accepting submissions, is a high-risk application with has a high impact if you have an incident there. The data is very sensitive, not only confidential information for your company, but also privacy rules, GDPR, HIPAA come into play here. And if the iPACS is in a public place, then it has to be considered a high-risk application. That's why the whole the security component is paramount for us. We do have extensive training following the OWASP principle. That's a project that looks into training plans for web developers around web application security. And where we provide that to our developers, the DevOps people and our testers, so that they are aware of what they should look out for and avoid issues. We also do code reviews, in particular of critical code paths around authentication, APIs, and so on, to just have 4 eyes look over changes. We have developed a nicely working hardened web server configuration that we deploy to avoid click jacking or cross-site scripting attacks. That's something that you have to monitor continuously. That's why we, for 2.03, we used 4 different web application scanners to check out if there were any findings. They found a few things that we then addressed, but no major issues here. Since a couple of weeks, we are also getting we engaged Qualys for daily penetration scanning tests, where they're looking at vulnerability of known issues for our public infrastructure. And we also monitor our firewalls on an hourly basis to see any changes. So thinking about what are the security features that are built in iPACS 2.03, and most of them also in earlier versions, we really spend a lot of time in finding an optimal configuration of HTTPS, which is the version of the web protocol that is fully encrypted. And we also let that certify and monitor externally. There's a great tool called Qualys SSL Labs, where we get an A+ rating for our configuration. And we're using only secure algorithms. But it's not trivial to get that set up in a way that still all your users can access your website, but it is secure. We also highly recommend to use centralized user management, in particular if you have multiple iPACSs that you work with. At Invicro, we actually have dozens that we have to manage, and if somebody departs, it would be a real pain to have to go to each individual one and deactivate users there. That's why we highly recommend and see this as a security feature to use centralized user management like in Active Directory or LDAP, and then just have a single place to disable users or manage their access. Something that is new to iPACS is that we added multi-factor authentication. So you can you scan a QR code in with your phone, and then every 30 seconds you get a 6-digit code on your phone that you have to provide in addition to your passwords, which is a great way to avoid phishing attacks, where you get an email from could be your boss and asking you to log into that website, and you then disclose your passwords, and then they would have access to that iPACS right away, so that you're still able to use API calls, for instance, or you have background jobs or iPACS sync. We also have app passwords or app tokens that have limited access control, and you're not exposing your actual Active Directory password if you're using them. Rhonda will give a little bit more detail on that front. Very important here also is the full encryption of all transfers that we have in iPACS. When you're using HTTPS, then everything that's getting transferred from you to iPACS or between two iPACS systems is fully encrypted. And we optionally very often request it, and makes a lot of sense if your data is in a third-party data center, is also the encryption at rest. That's the data is also encrypted on the system itself. And if, for instance, somebody would break into that data center, steal the computer, or components of that computer get reused, that there's no leak of data out of this. The HSTS, the or the HTTP strict transport security, is an often overlooked but crucial part that we are also covering, because if you have an attacker that's between you and the iPACS, it would be very easy for them to just point you to an HTTP version of the iPACS. And unless you're checking the small lock sign in your browser, you might not notice that you're actually on a plain text version where they can read all the communication. And HSTS allows iPACS to tell browsers, I'm only talking HTTPS to you. If the user tries to go to a plain text version, then show an error message, so that they are aware of this. The downside of this is you can't go back. So once you have made that decision, you are locked into HTTPS. But for our application, that's perfectly fine. On the encryption side, perfect forward secrecy is kind of the gold standard for how to do the whole key exchange, because it allows you to keep the data secret even if your certificates, like in a break-in, would be disclosed later. Then previously recorded communication to that server could still not be recovered by the attacker. So that's also a very useful feature that we have implemented there. And we of course have a firewall around the iPACS, independent of whatever you and your IT team does. The iPACS itself also comes fully firewalled. We use secure passwords resulting, so people can't use tables, password tables to attack the passwords themselves. And we have also counter methods against cross-site scripting and cross-site request forgery and SQL injections, all bits built in right into the iPACS core to make it very easy to use them. The other big feature that's also slightly security related, but the benefits are even higher on other areas, is that we have containerized iPACS, put it into small components where the web server, it's its own container, the iPACS application, the database, the search engine are all in small containers that are similarly to virtual machines, but more lightweighted, because we're not emulating a full operating system, but just keep processes separate from each other. And that allows us much easier and consistent deployment, because we are now creating images and have a separation of concerns, and can just deploy iPACS in more environments more easily. Also, the immutability is very useful from a security standpoint, because you can change the iPACS code once it's deployed. And the images are unchangeable. That also makes validation much easier if you can, in a very consistent way, independent of the operating system version or things like that, deploy always the same iPACS. Similarly, on the portability side, it's very easy to then move the images to a different host environment, different hardware, different software like operating system versions. And thanks to the lightweight visualization that we have in containers, we get much better performance out of this with only minimal overhead of this. Then an area that we are still exploring further is also the scalability, where we are looking then into, instead of having just the integrated container for the search engine, for instance, you can swap it out for an entire cluster of Elasticsearch is the engine that we use there. And since everything is just defined on the interfaces between containers, it makes it just easier to exchange things, or also have services run on different servers and scale it up vertically and horizontally here. And last but not least, as I mentioned, is also the security. Like if you break into the iPACS application, you are locked into that container, and it requires additional effort to get out of that before you then can, for instance, access the database with the user information or some patient information, or get to the file system from there. Long story short, for our we are prepared very well with our infrastructure for clinical trial data storage. We have been audited, I mentioned that about 100 times. We have our certification. We are GDPR compliant, which all of us, or many of us, had to go through in the last couple of months since May. We are still registered with Privacy Shield, and we have our production data center located in New Haven with full replication to the Boston site. So we are also prepared for disaster recovery and business continuity on a larger level here. So now I wanted to look a little bit into the core lab workflow that we have. So similarly to Jacob's image, we get images from these 900 sites, have to standardize and do image QC, and read and quantify, and then store data back, and finally report out. On the upload side, it's a hard requirement for us that no software installation is needed for the submitting site. We have to keep this simple to not lock anybody out. We used to have a Java client there, but more and more hospitals, sorry, there's timing here on that slide. More and more hospitals are actually disallowing such clients, so we have to really concentrate on just an HTML uploader, but still have to support large files and continuation of requests that stopped for whatever reason. And that's an area that we invested a lot of time in to look into how to get this right and make it easy to use. Then the whole de-identification is of course crucial for us to make sure that we don't pull in PHI or personal information into our data systems. And if you deal with that on the submission side, it just makes things much easier for you. And then also automated quality checks are really important to just raise issues and avoid that humans have to find them. There are a lot of checks that you can do to find issues automatically. So that's the setup that we have built for our core lab, where we have a submission iPACS that is public facing with a uploader that scales to whatever browser capabilities we have on the submitter side, where we can run the de-identification as well as the initial QC, and only keep data for a limited amount of time, because the submission iPACS is a publicly available iPACS. So it's also an advantage for us to only have data from the last couple of days there while they're getting processed, and not have the entire data warehouse exposed on the internet. And once the data is past the initial QC, we can pull it in to the internal data iPACSes that we have at various sites, depending on who's in charge of the processing. As you know, we have sites in Boston, New Haven, London, and Doylestown. And all of that is also then overseen by iCro, which is our project management system based also on the iPACS infrastructure, where we do a lot of where we do all our all our project managements, also invoices and revenue recognition are done there. But as Jacob mentioned, we also do our site center setup is controlled there with the so-called first patient in notification that we then send out after full validation of the site, that they are allowed to start imaging on that project. All the user management for the submission iPACS and the so-called communication tool is also managed on the iCro, with the communication tool being that part that knows who to notify whom on what situation. Like we have different query types around the imaging or around the patient, and then the iCro knows who's to be involved in that with their email address and contact information. And from there, then on the internal sites, you have seen that done by, you have seen example workflows from Jacob. We are doing the processing based on the internal data iPACS, and from there it gets can then get exported to a sponsor iPACS, where we can provide the results and reports, and they can access their data specifically. And here just some examples of how this works. So you set up full study protocols. It pulls in the sites and submitters from the sites center setup tool of the iCro. You can configure your de-identification, either set up automatic rules to do this or manual ones, and also configure your QA/QC checks that you want to have performed. Particularly on the DICOM identification, which is also a module that's available for you, we try to follow the DICOM standard, but there can still be a lot of PHI in DICOM headers, as you know, in private fields or in fields that are misused for these purposes. So it's also important that you have flexibility in the rules that you can set up, and worst case also intervene manually to remove header values along the way. And also by keeping all of that just on the submission iPACS, we avoid a lot of privacy issues, because we're never pulling in PHI or personal information into the internal data mart, where then the entire analysis team would have access to the data. We really try to handle that in a demilitarized zone, kind of outside of the actual working horse here. And then integrated into that submission is also a self-service dashboard where the clinical sites can find all the queries that we have associated with the data that they uploaded, and then they can respond. And this is the advantages. The high integration here allows us to have quick turnarounds, and we avoid just sending out emails that might or might not get to their recipients. And everything stays together, the queries, the data, and we can then also have a complete audit trail of what happened along the way. This is an example for a submitter view, similarly to the forms, to the case report forms that Jacob has shown you. For each protocol, you define what input you want to collect and add constraints and limitations on what you want there, or as Jacob has shown, if you want to answer a question with yes and no, then it could expand into, please tell me more about why you said no here, and put that in. There's the whole accept reject workflow with immediate notifications to the internal team of what happens to a data set, as well as to the outside site. So there you don't have to send emails manually. Everything's nicely integrated in here. And then lastly, we have this workflow tool which shows the status of every single image within the system. What's the current processing step? What should happen next? On which desk is it currently in? So that we also can have escalation rules. Like if somebody hasn't looked at that image for 3 days, then a supervisor gets notified. Maybe somebody is on vacation or out sick or doesn't have the time to process the data. And all of that has been integrated to make our core lab more useful. This the screenshot for the query responses. And lastly, that's something that we're working on more and more. And Rhonda will show a small example about this, also integrating dashboards, in this case using a business intelligence tool. This is based on Microsoft's Power BI, where we take ICRO data and visualize that in dashboard. For instance, here, all production facilities that we work with, which have to be within 4 hours of the imaging centers that we are trying to enroll. So it's a useful tool to see that live, integrated in iPACS in this case. So for the next version of iPACS 2.5 and beyond, the 3 key focus areas for us are really data accessibility, the workflow automation, and scalability. And that means that we want to continue our work on the APIs and allow you to use your tools for reporting and data mining, either for processing in MATLAB or using business intelligence tools. The DICOM server is also still a very popular, if not the legacy interface, but we are also working more on making that compatible in even more situations. And also part of that would be the integration into single sign-on infrastructures, which help you use iPACS in a bigger environment as one data mart in your entire warehouse setup. On the workflow automation side, the processing pipelines where you can run processing jobs on iPACS for on your data that's there, and you don't have to download it, process it, and upload the data again, but everything stays on the iPACS infrastructure is a key part. And also the user trainings, like we had the workshop yesterday, I think are crucial here to make sure that you can use iPACS to its full potential in your studies. And on the scalability side, the enterprise level storage, I mentioned we see larger and larger instances of iPACS, and we have to adjust to the requirements that we see from our customers and you as our users here. Particular object storage as well as distributed file systems are big topics for us here. And that again also comes with, we continuously have to improve our indexing and the search cluster to just keep up with the amount of data we have. And we are also wandering or getting into some areas where we see really large data sets that are hundreds of gigabytes large from coming out of histopathology that are tricky to deal with, and we're looking into solutions for these areas by streaming data and having multi-resolution workarounds to be able to make such large data sets accessible from the iPACS. Thank you. Any questions?
We do have one. We do have one on online. It says you mentioned that version 2.03 is going to leverage Docker. Are there any requirements in terms of upgrading or anything like that from a server perspective that's required for that?
Yeah. So the current deployment is then on our CentOS 7 or Red Hat 7 system, but in theory, Docker allows us to be more flexible with the deployment environment, and that's an area that we're working on. But we have fully validated it in that Red Hat 7 environment. So that would be our current recommendation. But our future plan is actually to get away from too strict requirements on the operating and deployment environment side and make it more flexible. Thanks.
Great. Oh, we've got one more in the room.
Yes.
There was another one online. It says, have there been any recent efforts to integrate the iPACS into cloud-based infrastructures such as AWS or Azure?
Yeah, iPACS can be deployed very easily into AWS. We actually do that a lot, either in private clouds. We do that for customers, or also in the public cloud. So that is kind of our standard mode of operation these days. Muslim.
With the AWS installations, do you have multi-factor authentication enabled, and how does it work?
It's currently optional, but we try to make it as user-friendly as possible. Like in our setup, we have we started making it mandatory for all admin users, and then for some power users, and you can actually do that based on iPACS roles. That you say those roles should be mandatory mandatory multi-factor authentication users, and then they get every time they log in, they get a friendly reminder that they have 30 days left to complete their setup, and after that time you have to contact your IT team. But in that time they can just help themselves. And also, if you access it from known networks, like from our production networks at our 3 sites, then you're not bothered with the 2FA on a daily basis, but you can remember the setting for 60 days or a configurable number of days. So that's because I really believe in you should not try to fight your users. You should try to make it easy for them to do the right thing. And that's why we came up with a way to implement the multi-factor authentication to not annoy them too much, but still provide the protection that somebody not only needs their password, which is something they know, but also has to get something that they own, a physical object, in this case, their phone, which is much harder to do both together. It's kind of easy. You know, we have seen this, that people are giving up their password for a Snickers bar in the street, and phishing mails are coming in the hundreds every day, and they can be very sophisticated. And then you think you're logging into your Office 365 web interface, but in reality, you're sending your passwords to the Ukraine or some other place. And if then your whole security is just based on something you know, that is too risky in an open environment.